SOHCAHTOA. That's what we're going to do today. SOHCAHTOA. And that's not my my favorite band or anything like that. This right here is dealing with right triangles, and it's the start of trigonometry. All right, so we're going to label a right triangle A, B, and C. Okay, I'm going to go ahead and put some measurements on here. 4, 3, 5. If I take 3 squared and I add that to 4 squared, I will get 5 squared. Okay, so that is a right triangle. All right, SOHCAHTOA is just an acronym. Okay, it's for us to remember the ratios of trig functions. That's a mouthful. Trig functions. Trig functions are sine, cosine, and tangent. S for sine, C for cosine, T for tangent. So what this actually means when we say so, it means sine of an angle is equal to the opposite leg of that angle over its hypotenuse. Okay? So let me give you an example. If we look over here and we do the sine of A, so sine of angle A, that's going to be equal to whatever the opposite of angle A is, which is 3, over its hypotenuse, which is 5. Okay? And so the ratio is 3 over 5. We can do that same thing with the cosine. So the cosine, though, is equal to the adjacent. So that cosine of an angle is equal to the adjacent leg over its hypotenuse. Adjacent means it's the other leg that kind of runs into that angle. So if I said, what's the cosine of angle A? That would be the same as 4, because that's what goes into A, over 5, which is the hypotenuse. So 5 is always the hypotenuse here because this is the right angle. It's the one that's across from the right angle. Okay. All right. So let's do the last one, which is tangent. So that's TOA. So tangent of angle A is equal to the opposite over the adjacent. So the opposite of angle A is 3 over the adjacent, which is 4. And so now the trig function and its ratio is 3 over 4. Now, you may say, what does this matter? Well, this is the start of how we can use SOHCAHTOA to solve for angle measurements and side measurements using trig. Okay, so at this point, make sure if you're using a calculator that it's in degree mode, not radian mode. Degree mode. Okay, to do that, you just find the mode button and you click it, and then you go where it says degree versus radian, and you make sure degree is highlighted. Okay, so what about if we just go ahead and continue and do the sine of B, not B, I'm sorry, C, the cosine of C, and the tangent of C. All right, so what's the sine of C? Well, the sine of C would be the opposite of C over the hypotenuse. So the opposite of C is 4 over 5. Notice that the sine of C is the same as what the cosine of A is. Okay? It's all trig. It's all it is. The cosine of C would then be probably the same as what the sine of A is. So let's check. So the cosine of C would be the adjacent, which is 3, over the hypotenuse, which is 5, and it is. And the tangent of C would be the reciprocal of what the tangent of A would be. So the tangent of C is the opposite, which is 4 over the adjacent. Now, I will tell you this. We will never do the sine, the cosine, or tangent of the right angle. Okay, we can't do that. It's only for the acute angles. So when we look at the acute angles in a right triangle, A and C in this case, those are the things that we can use SOHCAHTOA for. And all it is, again, is an acronym so that we can remember these ratios. Okay, so the tangent, I didn't write it down, but let's go ahead and write it down. The tangent is the opposite over the adjacent. So I have this, this, and this, and that's what this whole acronym means. Sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and the tangent being the opposite over the adjacent. Now, This all goes with the angle. So the angle measurement will always go where the trig function is. Okay. We didn't have an angle measurement, so we just put the actual angle there, and that's fine. So this is just the start. I just want you to learn SOHCAHTOA. So start to put that in your head. SOHCAHTOA. All right. Toodaloo.